Hello, everyone. Good evening. The authors and invited guests. Welcome to Technical Session 6B. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information Communication Technology for Competitive Strategies, ICTCS 2024, Jaipur, India. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 20th and 21st of December 2024. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to the chair for this session. We have with us Dr. Latika Desai, who is currently working as an associate professor and academic administrator, as well as the IC head of the IT department at Dr. D.Y. Patil College of Engineering, Akurdi, Pune, India. She has a total of 25 years of teaching experience and has published 33 papers in various journals. She also holds 2 copyrights granted by Government of India. Her areas of interest include digital electronics, data security, embedded systems, and IoT cloud. We welcome you, ma'am. I'd like to invite the next paper presenter. We have Gauri with the paper titled AI-Powered Chatbots in Public Services, the Case of PostQuest for Government Schemes. Ma'am, if you're ready, then you may start with your presentation.
Yes.
Yeah.
Is my screen visible?
Yes, ma'am, it is visible.
Okay. So good afternoon, everyone. Myself, Barge Gauri. The title for our paper is AI-powered chatbots in public services, the case of PostQuest for government services. So this research paper comes under the track of ICT for e-governance and government. We are from VIT Pune. So this is the agenda. First of all, we'll be discussing the problem description, the idea. So the problem that we have tried to solve using our application is creating a AI chatbot for government scheme awareness that will provide an interface for users to easily interact and get information about those different schemes offered by the government. So for creating the chatbot, we have used the data of Post schemes. The application provides a user friendly interface for the users to get accurate and instant information of different schemes. This chatbot automates the responses and reduces the wait times and improves the customer satisfactions. So the customer don't need to visit a website and research about the information. Suppose he want to open an account, so he don't need to search about it, what uh, are the requirements and all on the website. Instead, he can use the application, and in just one query he will get all this information. So this will enhance the accessibility to public services, and users will use these services more frequently. This overall, the PostQuest application efficiently manages the customer queries, and this is a mixture of AI technology to improve the public health services. Following is the research survey that we have carried out. So different AI chatbots are currently present under different domains such as public transport, academic advising, mental health, etc. So we have understood the application of all those chatbots in those services, and we have taken the features from those research papers, and we have tried to build our application. So the features of our project are providing solutions to different queries related to different schemes of India Post, such as eligibility, whatever the required documents are there, interest rates, features, and benefits. So the application accepts the data in form of text and gives output in form of text. So similarly, the communication is possible in text to audio, audio to audio, as well as audio to text form. The application also supports multilingual communication. So instead of just communicating in English, the user can communicate in their own languages, in their own mother tongues, so that their user can more use this application more efficiently in their own mother languages. So to evaluate the performance of machine learning models, we have done comparative analysis of two models that are mostly used, and that we have analyzed that most of the chatbots are using those models. First one is the Mistral and the next one is Llama. The next feature is user-friendly UI. So following are the objectives. First of all, to increase the awareness about different government schemes. The next one is to improve the accessibility of the information to the general population. Then simplifying the information, to present the information about the schemes in simplified and understandable manner to layman. Then the next one is facilitating the decision making. Suppose user want to open account for scholarship purpose. So with the help of chatbot, he can give multiple queries and understand which type of account is suitable for him for his own purpose. And the next objective is to bridge the digital divide. Means there is a gap analyzed between the normal phone users and the technology. So this, as this application is user friendly, this will reduce the digital gap between the users and the technology, and the users will more frequently use this application. The tech stack that we have followed is languages, first of all Python with Flash for the backend, then Python with Jupyter Notebook for training the machine learning models and other stuff. Then for the front end part, we have implemented an HTML, CSS, and JavaScript. The Python libraries that we have used, first of all, is the transformers for NLP, then Google Trans for supporting the multilingual support. The next one is the Google recognition for the audio, enabling the audio input, and below three are the libraries that we have listed that are used for fine tuning and training the LLM models. Next part is the data set. The data set that we have used, because the data regarding there was no such data set regarding the post schemes. So we have created our own data set, which consists near about 1000 questions. We have deployed it on a Hugging Face platform, and it is in format of JSON. So for this, we have used different techniques such as web scraping, and data, we have referred the data from the official website of Post, India Post. So the models that we have studied in the research paper are the Mistral 7B Instruct and Llama 2 13B Chart. So these two models, we have analyzed that most frequently these two models are used. But we were in confusion that which model gives better performance. So for that, what we have done, we have trained our model on we have trained our data set on both the models, and we have found that Mistral 7B is more efficient than Llama. So further, we have used Mistral model. So this is the system architecture where the common users interact with the web application for the user. So user can give input in form of audio or text. So when user gives query other than English language, then a translator is there which will translate those queries in English, because the data set is in English. So the model is trained on English language. So there will be a translation of those, suppose queries in Hindi, it will get translated to English. Then it will be sent to the NLP. If it's a valid request, it will fetch the data from the data set, and a user response will be generated and given to the user. Similarly, for the audio input, there is an audio recognizer. which will take the input as audio, then it will convert it into the text and it will send to the application, that is the NLP. It will again generate a valid request and send to the user. So this was the simple architecture which tells us how the system is working in rough way. The methodology that we have followed for creating the entire application. First phase was the data collection and information gathering phase, where we have analyzed different resources from where we can get data about this India Post schemes. So we have collected data from the website, other social media websites where different queries are listed regarding the schemes such as Cura. And once we have gathered the information, the next stage was the dataset preparation. As I have mentioned this earlier, we have created the dataset near about 1000 questions using web scraping and other tools, and we have deployed it on Hugging Face platform. The third stage was LLM training and fine tuning. So we have trained the two models, that are Mistral 7B and Llama 2. We have analyzed their efficiency, and after fine tuning and training and testing, we have found that Mistral was performing better on our dataset. So we move forward with the Mistral. The next stage was creation of the user interface of the chatbot. So we created the front end, then we integrated both the back end and the front end together, and further on testing and evaluation of the chatbot was done. So for training and testing, we have understood different black box tests, such as whether it is accepting different inputs, form of inputs like audio, text, whether it is taking different languages and translating it properly or not. And we have also analyzed accuracy of it.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay.
Yeah.
So this was the implementation where there is the different user can select different languages. He can just type the question and send the query. In response, the Postgres application will give them a response. Here we can see user has asked the interest rate about the post saving account. So the response is generated that the interest rate for saving account is 4% and all. Similarly, audio input is given here. This is the comparative analysis that we have done. Mistral 7B model is having what we have analyzed, that on our data set, it is giving 67.45% of semantic accuracy, and Llama is giving 59. And not only on our model, but we have reviewed different research papers as well, which precisely tells that Mistral performs better than Llama. So we have moved forward with the Mistral model. So this is the conclusion part, that we have tested both the models and that are giving the respective accuracies. So therefore we have fine-tuned the Mistral model, and that is only used in our application. And regarding the accuracy, we have used a fuzzy logic for deriving the accuracy at the threshold of 85. The accuracy rate that we have got is 97%, 97.13%. Talking forward with aspect of future work, this Postgres application can be integrated with different services such as payment gateways, document submission portals, and tracking systems to enhance the user experience. And chatbot can collect and analyze user data to gain insights for customer behavior and analyze the different trends in user input as well. And not only in the sector of banking, the chatbots are very efficient and useful in other ways also. This can be integrated into healthcare sector, academics as well. So that's all. These are the references that we have mentioned earlier in literature survey. And yes.
Thank you, ma'am. Ma'am Latika, would you like to ask any questions?
Yes, nice presentation. Have you implemented the system completely?
Uh, yes, ma'am, we have implemented the system. Should I show the demonstration? We have recorded a video of the output.
No, no, just I want to ask you, have you checked the previous researcher results with your results? For example, accuracy, you are saying 97%
Huh,
you are achieved,
huh,
right? So have you
yes.
checked accuracy with any other previous researchers?
Ma'am, regarding the accuracy, what we have done, the data set is created by our own. Na? So we have implemented the fuzzy logic. Mostly this logic is used by majorly while comparing analyzing the accuracy of the chatbots and all. Fuzzy logic is only used. We have seen that different researchers are getting different input, different accuracy near around 95 to 98 percentage is the range which the researchers are getting.
Okay.
Yes,
Okay, thank you.
yes.
Over to Ishita.
Thank you, ma'am. Our first presenter, Sir Saurabh, if you're ready, then you can go ahead.
Yes, ma'am, I'm ready.
Okay, sir.
Ma'am,
Yes, sir, your PPT is
yes, ma'am.
visible.
Okay, ma'am. So, should I start now? Am I audible to all of you? Hello, everyone. Today I'm sharing the insights on a comparative study of elastic optical network and wireless data transmission technologies. Myself, Saurabh Chandra, one of the assistant professor of Netaji Subhash Engineering College. My department is CSCIML. Let's dive right in it. So it's clearly a review paper where this slide shows the data transmission has comes now a long way, wherein to the meet of the growing demand for the faster and more reliable communication. This study focuses on two key technologies. One is elastic optical network, which provides the backbone for high capacity network, and wireless data transmission, which ensures the mobility and real life connectivity. The goal here to compare their principles, advantages, challenges, and how we can apply them in real world. Now, elastic optical network (EON) are all about the flexibility and high performance. They uses fiber optics and dynamic wavelengths allocate and manage the bandwidth efficiency. They are great for handling heavy data loads in applications like cloud computing, high performance systems. Ions are the fast and scalable, but the downsides of it that high setup cost and complex maintenance. Now, compression versus Ion and wireless data transmission. That Ion, I already told that Ion is all about high data capacity, low latency, but and it is based for the data intensity and long distance applications. Where wireless data transmission is all about the flexibility and the portable solutions for the user end devices, enable the real life connectivities and in mobile and IoT technologies. Now, the applications where we can apply the EON in large cloud data centers
Excuse
for
me, Saurabh sir.
yes, ma'am.
Slides are changing.
Yes, ma'am.
My slides are the same. So,
What a minute, ma'am.
hello, Ishita ma'am. Slides are
Yes, ma'am.
changing, na?
Ma'am,
Changing.
the current slide was on the fourth one. Was it
Uh,
the same for you?
Now it's fine, sir.
Okay.
Thank you.
Yes, sir, you may go ahead. Continue, please.
Now, is the slide just showing enough?
Yes, sir. Yes, sir.
Yes, now the applications of data wireless data transmissions are IoT and smart cities, healthcare for the remote monitoring and telemedicine can be done, and AR/VR of low latency communications. Now we can build hybrid models by combining these two different technologies, means EON and RF radio frequency. So we can get the benefits like scalability, reliability, which can support the variety of applications from smart city to global enterprise connectivity. Now, to wrap up the EON and wireless means RF technology with each other, together they can balance high capacity and mobility, addressing the diverse communication needs moving forward. We need to focus on the making of these systems more scalable, cost efficient, and energy friendly. Now, to make this paper, I have used these references, these 30 references. Thanks a lot. Thanks a lot, ma'am. Do you have any question? Hello, ma'am.
Yes, sir.
Hello.
Yes.
Very
Hello.
Yes, ma'am.
Yes, ma'am.
No questions, sir. Thank you.
Okay, thank you.
Okay. In the meantime, we'll proceed with the next paper presenter. We have the next paper presenter, Huang, with a paper titled Effectiveness Investigation into Lightweight Models for 2D Object Detection. So if you're ready, then you may go ahead.
Yes, yes.
Yeah.
bớt không bị điện tử bạn bóc lột bị sờ cam đó này, có thể bị sờ cam. Cái phòng gym tức là em tập ở đó được 1 năm rồi, xong em tiếp tục em đăng ký em tập tiếp 14 tháng. Cái hôm kia em lên trên cái thấy nó thông báo giấy thông báo nghỉ, tức là nghỉ 6 tháng luôn. Cái phòng gym được 6 tháng.
See my screen now?
Yes, sir, it is visible, but we have some background noise from your side.
Trước giờ tập cũng uy tín này.
Okay, so 5 minutes I will move to
Nghe giống giống một tháng trước là dẹp một cái bên hai rồi, cái này dẹp cái tự nhiên nó làm cái đùng cái PT nó hồn PT lên thì không biết gì giờ PT
Hello.
Yeah, sir.
Okay. I'm Trọng Anh Nguyễn from Vietnam. I will present our paper, Effectiveness Investigation into Lightweight Models for 2D Object Detection. Is the agenda. Okay. Nowadays, the 2D object detection models is increasingly developed, but more of them now is very resource consumption. So if we want to apply it into autonomous driving or camera security, we need it to run on the edge device such as NVIDIA, and NVIDIA embedded system is very developed for this task, and it's dedicated for the edge device and edge AI. So in this paper, we will investigate how we can deploy a 2D detection model such as YOLO or SSD into embedded system like NVIDIA Xavier Jetson NX, and how can we remain the accuracy while boost the performance. It is the 4 points of our study. First, we the study on a strategy to adopt AI model on hardware limited system. Second, we reduce the lightweight detection models, and we analyze the trade-off between the performance and efficiencies. Finally, we leave a roof of possibility to run on a resource constrained system. The related works. There are several kinds of object detection. First, here, first one is you can see like CNN, faster CNN, and fast CNN is very famous for the reason repository net framework base. Overall, they will use some algorithm to extract the reason. For example, in RCNN will be 2000 reason using some classic algorithm. And for faster RCNN, they use the AI module for this purpose called RBN, or Reason Proposal Network. And the CNN, the detection module will calculate the class and classify them into the object result or not, and the pattern box regression too. Beside them, you have a model like SSD or YOLO. Basically, they divide the image into the grid, and each grid will be the possibility of the objects availability. For example, they divide the feature map or the input into the grid, and each grid will have some of the pattern box, redefined pattern box, and each of them will be evaluated to become loss and backward to the model. And about deployment, embedded deployment strategy. First of all, we will have a model and we optimize them using three techniques: the quantization, pruning, and knowledge distribution. The quantization is that we convert the weight of model from floating 32 to the int or the floating 16 or int 8. So the model will be lighter and be able to run on a limited system related to the hardware resources. Knowledge distillation, we use the bigger model, better model called teacher, and we have the target model is student, and we distill the loss. Pruning in a way we cut up some useless module or useless weights so that the model will become lighter. And by the quantization, we have got the post quantization or quantization aware training. Post quantization is that after we training, we quantize the model and remain the performance. Quantization aware training is that we train the model that the way used in 8 or floating point 16. About the hardware deployment, we have the variety of the hardware from the NVIDIA, and we use Jetson Xavier with 6-core NVIDIA Camo ARM and GPU of 384 core with 48 tensor cores. This is the very famous options for the embedded system like camera or for the autonomous driving system. And obviously the right is reasonable. What are my thoughts? We select the YOLO V5 due to it the efficient module, and it's very famous and very efficient. Performance is very good. This is the whole pipeline of the module. As you can see, we receive the image usually normalized to this side 640 with the channel is 3, and we have backbone to extract the feature pyramid. After that, we will have a next assembling them and fuse the feature from a multi-scale. After that, we will have 3 scale. This scale will predict with the prediction. That means that the model will predict with 3 different scale, make the model more robust. About optimization method, we utilize quantization from floating point 32 to floating point 16. Moreover, we utilize model fusion strategy and framework-based optimization. Framework-based optimization is the way we utilize some famous framework of NVIDIA like TensorRT. This framework combine many of optimization methods, layer tensor fusion, kernel auto-tuning, multi-stream execution, dynamic tensor memory, and precision calibration. Here is the unoptimized network. You can see that a lot of model is duplicated, make the memory is bigger. In the optimized network, we only have the one model CBR one time once here, and each module one is called, we get the weight from the RAM instead of duplicated and store it to the memory. This makes the process infer very speed compared to the original model. About the experiments and evaluations. Here is the YOLO with 5 models running on Jetson Xavier NX, and I have recorded. As you can see, when the param increase, the speed increase synchronous. And for the comparison, we select YOLO with 5X, M, and L model.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Sorry, what?
I'd like to remind you regarding the time limit.
Okay, I will finish.
Okay.
As you can see, the increasing pitch after converting to floating point is 16 is very much, about 70%. And this is another table on the custom traffic light set, like proven that the efficiency on the among the data. Conclusion that we conduct a variation model survey, deep learning for 2D object recognition. Also employ YOLO VNAP and TensorRT in a 10C experiment, demonstrate quantization effectiveness. So it indicates there's a strong potential for deploying optimized models on embedded system. Thank you very much for listening.
Nice presentation, informative. Optimization, what is the benefit of optimization in your research?
Thank you for your question. The benefits of optimization is that you can run the model AI on the hardware constraint system. For example, you cannot bring the GPU to the car because it's very inconvenient and power consumption. But with embedded system, the power is limited. That means it uses less power, less electrics, but you could able to run the model AI so that it make the autonomous driving system is very potential. And yeah, we can run the model AI on the edge device. Don't need to the big CPU.
Okay, thank you. Over to Ishita, madam.
Thank you, ma'am. We'll be proceeding with the next paper presenter. I'd like to invite paper presenter Shivam with the paper titled Improving Item-Based Collaborative with Vision Transformers to Address Data Sparsity Issue. So if you're ready, then you may start with your presentation. Sir Shivam?
Hello, am I
Yes,
audible?
sir. Yes, sir.
Yes, just a second. I'm sharing my screen.
Sure, sir.
Am my screen audible?
Yes,
Visible?
yes, sir. Yes, sir.
Yes. So my name is Shivam Madeshna. Today I'm here to present my research paper, Improving Item-Based Collaborative Filtering with Vision Transformer to Address Data Sparsity Issue. My co-author Ronak sir, we are from Chandubhai S. Patel Institute of Technology, Charuset, and my co-author Priyank Thakkar sir is from Nirma University, Ahmedabad. So this is the table of content I am about to discuss today. So basically, the motive of our research paper is to address an issue. Every time when recommendation systems, which are using a variety of domains such as e-commerce or streaming services or any online marketplace, by providing their personal suggestions to the users, but at some time when users are getting much more in data set, but the items are getting lesser, or items are getting smaller, but users have not reviewed their system or their data, then it could be a data sparsity issue. When we are using an item based collaborating filtering, it will be cleared and it will be helpful to address this issue. And in this paper, we have used vision transformer, which is a kind of a new technique where we can gather different types of information or features from various images, and it will helpful to self-attestinate our mechanism, and it will be helpful for relationship between visual data. So recommendation system, it is basically a digital platform where it can be used for presence or behavior of different types of decision making or increasing user satisfaction or deriving engagement. So recommendation task in our part is based on image based. So as we know that images are built from pixels. So in this case, we are using different types of CNN models for comparison with VAT, which could be helpful at the end when we are discussing the part of comparative analysis. So this is the literature review we have mentioned in our research paper. These are the most used papers, and these are the examples built by the people who have worked along this kind of way. So this is the methodology of our research paper, where we have used Amazon dataset, which is around 40,000 of images, in which around 10,000 of images are unique and around 20,000 of new users have been listed in our dataset. So first of all, we are loading the different images in our model, which can be through VIT or CNN. As I said, we have used in comparative analysis. So first of all, the features have been extracted through tensors. So it will be in the form of tensors, which is represented in the form of vectors. So our targeted images is seen in an image. So after extracting the features, it will be sent to the item-based collaborative filtering method, in which a cosine similarity, which is a very pronoun and very much used method to use case different similar items between different images. So what it will do, it will just compare and it will cross multiply, or we can say a dot product, the different vectors of every images. So for example, 256 by 256 image will be there, then there will be a multiple of 256 by 256 different types of vectors, it will be there. So it will give a point zero something integer, which will be similarity between their vectors, and out of that we will get a similarity between two images. So in our part, we have rated different images through 1 to 5 rating of images. So it will predict that this image can be uh, recommended to 1 to 5 scale of scalability. So this is the prediction, and it will recommend top 5 images from an input image by any user or any application. So this is the methodology I have talked about previously. So loading the images, feature extractions, feature vectors, and item filtering in similar items, and rating will be predicted through that for top 5 recommendations. So this is the analysis of our finding. As I discussed about earlier, we have used a comparative approach, where we have discussed that different types of CNN models have used. In our case, we have used VGG16 and ResNet 50 for our comparison with Vision Transformer, and we have used RMSE, MSE, and MAE, which are the comparative methods to find out the outcomes of different models between their predictions. So as we can see that VATS perform good in RMSE and MAE and MSE also. So this could be a great approach for image in future. So this is the computer efficiency, where time taken for every part of calculating different multiplication, or we can say the cosine similarity. So Vision Transformer have taken the less time for computing every type of multiplications taken in each part of vectors. So it is a good approach for Vision Transformer. So after at the end, concluding my part, the VAT has shown an effectiveness in extracting visual features with item images. So we have used an RS approach in which item-based collaborative filtering shows and performance improvement on average and errors and reduction of time to find out the cosine similarity between VAT preferred and CNN extractions. So this is from my side. Thank you.
Hello. What is the limitation of your system?
So sorry. Yes.
What is the limitation of your system?
Yes. So limitations is not kind of much because we are using an cosine similarity, which is uh, globally used for kind of recommendations. But at the time of data sparsity, when different types of images have been more, but users have not reviewed that images. For example, when we are using any social media, any user has not rated that item, then other user who is fond to that item, but then that user will not get suggestions from that item. So that is kind of a sparse data, which is a limitation for which is a limitations. But in using item-based collaborative filtering, users can get different types of images, and they can get different types of similarities using vectors. So vectors will just manage their multiplication, and it will output the similarity for every type of user whenever they have not suggested or for item or not. So it is a limitation. It was a
Okay,
limitation.
informative answer, Shivam. Nice
Yes.
presentation.
Yes.
Thank you. Over to Ishita.
Thank you,
Thank
ma'am.
you, ma'am. Thank you, sir. We have the previous paper presenter who will go with the next paper presenter. I'd like to invite paper presenter Nikita Patil with the paper title Smart Energy Monitoring and Management System. Ma'am, if you're ready, then you may go ahead.
Yes, ma'am. Am I audible?
Yes, ma'am, you're audible.
Ma'am, can I share my screen, ma'am?
Yes, ma'am, go ahead.
Good afternoon, ma'am. I'm here to present my paper, Smart Energy Monitoring and Management System. Basically, in an era where energy efficiency and sustainability are paramount, there is a growing need and a very grave requirement for innovative solutions to effectively manage and reduce energy consumption. The smart energy managing and monitoring and management system basically is one such kind of solution which utilizes advanced technology to monitor, analyze, and optimize the energy usage in real time. It is designed for both residential as well as industrial applications, and this system leverages IoT platforms and microcontroller technology to provide a holistic approach to energy management. We have many of those traditional energy management systems, but we have got some of the drawbacks from them. Traditional energy management system face significant challenges, including real-time monitoring, inefficient energy utilization, and lack of remote sensibility. These limitations gives us the poor visibility of energy consumption patterns and prevent timely interventions. Inadequate energy management techniques across households, industries, and smart grids have resulted in increasing energy consumptions, higher costs, and have shown a very significant impact on the environment. Without integrated and intelligent systems, optimizing power usage and managing energy demand becomes a very big challenge. Inefficient energy use contributes to inflated electricity bills, risk wastage, and higher carbon emissions. This not only affects individual users economically, but also strains the power grid, highlighting the need for smarter, more responsive energy management solutions. The main motivation for developing this system comes from the critical need to improve the energy efficiency and sustainability. As global energy demand continues to rise to a certain peak, the environmental impact of excessive and inefficient energy use becomes more significant. Traditional energy management systems often lack real-time monitoring and remote control, which we have achieved through our project. The main objective is real-time monitoring. We have integrated ACS 712 current sensors, which are also known as Hall effect sensors, which enable an accurate and continuous tracking of energy usage for various electrical devices, efficient and cost optimization. The visible before?
Ma'am, it was visible. You can start from where you
Okay,
left
sure.
for because of the network issue.
This is fine, right, ma'am? Is it visible, right? This objectives and motivation.
Yeah.
Yes, ma'am, thank you. Remote control. Through ESP32 microcontroller, we have enabled Wi-Fi connectivity which allows users to monitor and manage energy consumption from any location. And this is the main block diagram of a project where you can see this ESP32 microcontroller, which acts as the heart of the entire system, which is connected to the LCD display, which enables local monitoring of the energy usage. This ESP32 is powered by a power supply through an adapter, and there is ACS current sensors which are connected between the electrical appliances and also the ESP32, which constantly monitors the energy consumption of each and every each and every load, and it provides the same information to the ESP32 microcontroller, which checks whether if a particular electrical appliance has exceeded the energy limit, then it regulates that particular appliance through this relay module, which is a 5-volt relay module. At the same time, the user will be able to track the energy usage of the certain power electrical appliances through the IoT platforms called ThinkSpeak IoT. Methodology we have used in our system, basically we integrate ESP32 microcontroller, ACS current sensors, single channel relays, and LCD displays for real-time energy monitoring, control, and data visualization. ACS 712 current sensors measure real-time energy usage, while the ESP32 microcontroller transmits this data to IoT platforms like Blink IoT and ThinkSpeak IoT over Wi-Fi. IoT platforms store and analyze energy data, providing insights into consumption patterns, inefficiencies, and usage times via intuitive visualizations. Basically, our system consists of two main subsystems. One is controlling subsystem as well as monitoring subsystem. Controlling subsystem mainly comes into the force when if electrical appliance exceeds its power limit. If it exceeds the power limit, then the ESP32 regulates that particular electrical appliance through the relay module. And we have got monitoring subsystem where the user can continuously monitor the energy usage of those particular systems through IoT platforms, as I said before. This is the system. This is the entire system we have integrated, and as I said, ESP32 microcontroller is the one which acts as the system's main part and which manages data collection, processing, communication with IoT platforms. ACS 712 current sensors measures the real-time current following through devices and sends the data to the ESP32 for analysis. Relay module controls the switching of electrical devices based on the energy consumption of that particular device. And LCD display is used for local monitoring of the energy consumption of those particular devices. These are the results on ThinkSpeak IoT platform. We have mainly used this platform to present real-time energy consumption data through clear and interactive graphical displays. It tracks and records energy consumption data over time, enabling users to analyze trends in their energy usage on daily, weekly, and monthly scales, helping them to understand their consumption behavior. And the platform also identifies periods of highest energy usage, assists user in recognizing and managing peak loads to avoid overconsumption and potential penalties. while coming to the conclusion, the smart energy monitoring and management system offers an innovative, practical, and scalable approach to address global energy challenges. By leveraging IoT platforms like ThinkSpeak IoT, along with advanced hardware components such as the ESP32 microcontroller, which is actually a 32-bit microcontroller with 8-bit SAR ADC and ACL712 current sensors, which actually work with which are actually based on Hall effect. This system ensures real-time monitoring and efficient energy utilization and remote accessibility. It also empowers users to analyze their energy consumption patterns, identify inefficiencies, and take corrective actions to optimize energy usage. These are the future trends and innovations, ma'am. We can develop the system in a very sustainable manner, as sustainability is a key aspect of the smart energy monitoring and management system. And also our project aligns with some of the United Nations Sustainable Development Goals like SDG 7, which means clean and green, clean energy, and SDG 10, which is smart cities. And we can develop the system by integrating more IoT platforms, which will make the system more user friendly. And we can also make the system by integrating it with renewable energy, so that it will play a very crucial role in facilitating the integration of renewable energy sources such as solar and wind power into the grid, maximizing the utilization and promoting a cleaner energy future. These are the references which we have went through for this coursework now. Thank you, ma'am.
Nikita, very nice and informative presentation, and the topic is also societal benefits.
Yes, ma'am.
So just I wanted to know, can you elaborate little bit related with the sustainability?
Yes, ma'am. Actually, our system aligns with sustainable development goals, ma'am. Like United Nations, we developed the system in such a way that it aligns with all, like most of the sustainable development goals, ma'am. It basically aligns with SDG 7, ma'am, which is clean energy, where we are supposed to develop a sustainable system in order to provide an environmental effective energy model.
Okay, thank you. Over
Yes,
to
ma'am.
Nikita.
Thank you, ma'am. Sir Yogesh, I have received your presentations, and I shall present the first one, and you can tell me when to move through the slides, if that's all right with you.
Yes, yes.
Sure, sir. Let me just.
Hello.
Yes, sir, you're audible.
Presentation.
So you may start.
Okay, so my name is Yogesh Rajput, and my presentation topic is optimizing flight operations, time series modeling for job volume prediction. Next slide. Next. In this research paper, a data-driven approach to optimize operational efficiency in the flight operations industry by employing time series models to predict the job volume for the sea exporting activity. So for this project, we have used the different types of algorithms such as time series algorithms, ensemble learning, and many more. So by gathering the pre-processing historical data, including forward flight informations such as job numbers, and we have applied the spatial data analysis to, and then that spatial data analysis called as the logistic systems, which use software to logistic industry to manage the data valuable inside the data. Next slide, please. For this model, we have used the exploratory data analysis. So for that, we have collected data from 2019 to 2021. So this data we have taken, and based on that, we have applied some time series model and this spatial analysis and ensemble model to predict the job volume for this like topmost countries. Next time, please. So just now we have discussed that for this research, we have used historical data, which is from 2019 to 21, and we have applied different exploratory data analysis to it, like pre-processing and removing unwanted information and all these things. Next slide, please. Next, ma'am. So this is our workflow. Like the name of our system is logis system, which is so logistic system. First of all, we have collected the historical data. Then we have applied the exploratory data analysis. After exploratory data analysis, we have performed 3 tasks. First is we have performed the spatial data analysis. Then we have applied the job volume data analysis.
And finally, we fit in the data into the time series model. Like based on this time series model, such as ARIMA model, we can come to know that like from which season we have a high rate of jobs and everything. Finally, we have applied the performance analysis by using root mean square error, MAE and MSE. Finally, we get an output in the form of countries which provide the most business, and the business reach out to all the world. Like by using the data, we know that which country have the highest job value and on which period they have a job value. Next slide, please. So we have applied the different algorithms. So I'll explain what kind of algorithms we have applied. So based on our data, so the assured Israel accounting 23% of the total jobs, followed by the Haifa Israel with shares of 12.36. So based on the historical data, we come across that the highest job value for the shippings and everything, which is in the Israel state, based on the our historical data. Next slide, please. This indicates that a significant concentration of business from limited number of ports. In fact, approximately 35.39 of the total business originate from only the two countries, suggesting heavily reliance on a small number of business partners. So this project or this research work will definitely help for the person who have like this data will help for getting the which countries require a high job value. We can't explain the complete information because this is industrial information. So we can't disclose many information about this project because this is actually the live project we are working on it. So yeah, that's it. Next slide, please. We have used the ARIMA model. So for that, we have used the data from 1918 to 21. And these are the different parameters like residue, seasonal, trend, and these are the job count. So as you can see at the 2021, there is a high job value. So because due to the lockdown and everything, then later on this everything was open, and that's the reason that the graph looks 21 is the highest. Next slide, please. So also we have applied this actual versus predicted graph. So first we have used the Holt Winter model. So to determine the optimal parameter for the grid search approach was employed. So the combination of parameters, the lowest was selected as the best model. Next slide, please. Yeah, this model, and we have performed the performance measures for this Holt Winter model, and we got the 0.94 is the mean absolute error, and yes, 0.942 is the actual value by the Holt Winter model. Next slide, please. Then we have used ARIMA model. In that we have plot a graph with actual versus predicted, and these are the what we can say the output we got based on this ARIMA model. Next slide, please. Finally, we have applied different performance analysis such as MAE, RMSE, and MAP. So the combination of the parameter revealing that the lowest RMSE was identified as the best model. So next slide, please. So overall, we have used three models, which is Holt Winter, ARIMA, and LSTM, which is large short-term memory. This model we have applied to our data, and we got the result. And finally, we have verified with the different accuracy measures. Next slide, please. So this is the overall output for the ensemble model, where we have used three models, which is LSTM, Holt Winter, and the ARIMA model. So this is the graph for actual versus the ensemble predicted. So as you can see in the graph, it is like it have a good accuracy based on this ensemble predicted models. Next slide, please. So this is all about our research work. Like we want to like predict that what are the future job count based on the data. So for that we have used three models, which is Holt Winter, ARIMA, and the ensemble model. Next slide, please. Yeah, these are the benefit of our research work. Like who will get the benefit after like this study is beneficial for the stakeholder in the industries, as they provide the basic for the resource allocation and the capacity plan. Next slide, please. Now, these are the references we have used, and thank you.
Would you like to ask any questions?
Yes. Informative presentation, Yogesh. You are used the combination of three models, right?
Yeah.
So I just want to ask you, what is the impact on the time complexity?
Actually, ma'am, this is the internship project I got from one industry. So they have given me one data set from 2019 to 21, and they said me that what are the like just use the predictive analytics and suggest that what are the job roles might be present after 2021. So for that, I've gone through some literature reviews. So I've come across that ARIMA is the best model for predicting the time series data. So for that the reason I've used ARIMA. Then LSTM model I have used because I've gone through with some literature review. So in that I found that LSTM is widely used technique, deep learning technique for predicting the time series data. So that's the reason I have used this three models.
Okay, thank you. Over to you, Ishita.
Okay, ma'am. Sir, Yogesh has another presentation. I'll be presenting it. So just let me know when to move through the slides. You can begin.
Yeah. Like one more project I've completed, which is on deep learning based building energy optimization using beam data and evaluating the energy saving potentials. Next slide, please. Next. So, like this project is especially for the architect. Like even this project is one of the part of my internship. So, building energy optimization is a crucial focus in sustainable practice and building information modeling, which is called as BIM. Is an individual resource for enhancing energy performance. So for this research work, I've used two classification techniques. First was support vector machine, which is the machine learning model, and I've used the artificial neural network, which is the deep learning model. So based on these two classification technique, I've compared the result and based on the accuracy measures. Next slide, please. So the investigation encompass the heating, ventilation, and the air condition. So it is called as HVAC system performance, orientation, and geometry of data. So our main objective is to save the energy by designing such kind of architecture. So the finding demonstrate that the deep learning algorithms, particularly ANN, offers a significant enhancement in the building energy efficiency, leading to sustainable energy reductions and the potential savings. So these are the basic architecture that we have, like whenever we are constructing the home. Next slide, please. The integration of beam data with the deep learning algorithm holds the promise for improving the building energy efficiency and the thermal comfort. So this study highlights the importance of accurately predicting energy consumptions and identifying the potential energy saving in the buildings. And we have used this BMI data from one of the industry, and they have given the data and we have processed this data. Next slide, please. So this is our workflow. Like first we have collected the beam data, then we have selected the parameter selection, like we have applied different statistical technique, like we have seen that whether it is empty, is there any empty records or any missing values are there that we have corrected. Then we have used the parameter tuning, which is the feature engineering. Then second part we have is the factor importance evaluation. So how we get this factor important evaluation by using the correlation analysis. So we have applied correlation, and based on this correlation, we have tested these data sets. Then finally, we have applied the performance measure using error analysis, and finally the accuracy comparison using RMSE, MSC, and mean square. Next slide, please. So as we already discussed that for this problem statement, we have used two algorithms. First is SVM and next is ANN. So as per our observation that ANN gives the high accuracy as compared to the support vector machine because it is the traditional model. So yeah, next slide please. So this is the result comparison we have. Like first we have this is the first graph is for the comparison of actual versus the predicted energy consumptions. So for that we have used two algorithms. First is support vector machine and next is artificial neural network. MSC for support vector machine is 0.16, whereas MSC for ANN is the 0.12. Like as we know that if MSC is less, that means that our algorithm is correct. So here the MSc student, that reason we suggest that ANN is good, whereas R square error is always maximum as compared to previous or any comparative technique. So here we have a highest R square is for ANN. That reason we said that ANN is best for the energy consumption. And finally, RMSC is also required low. So these are the parameters we have evaluated, and these are the graph. Next slide, please. So this is the comparison. Just now we have discussed that based on the both the models like support vector machine and ANN. So ANN give the correct result, and also it help us to save the energy consumptions by using this beam data. Next slide, please. So finally, this is the what we can say, like here is the proof that we have potential and energy saving. So as you can see that 11.59% energy we can save by using this ANN model. Like for that we have to done some pre-processing. Again, the data we have, but it's not genuine. Like they are not allowing us to like explain the data set. That's the reason I have only explained the output. Next slide, please. These are the conclusion which we already discussed, that we have used two algorithms, support vector machine and the ANN, and IANN give the higher class. Next slide, please. Next one. These are the references we have used, and thank you.
Thank you, Yogesh, for nice presentation. The
Yes, ma'am, please go ahead.
energy analysis as well as accuracy measures. So how you are doing these two things? Can you elaborate?
Actually, ma'am, we have one data set of one of the industry. I'm not able to tell. So they
No,
have
actual data set you are using, but how we are measuring the error analysis as well as accuracy, that you elaborate, okay?
okay. Like based on like whenever they are constructing the homes, so they have set some parameter like what are the ventilation and what are the height of that particular building. So based on that, energy requirements, like for example, if you have one room, in that you require only two lights. But if you can change the construction, like if you add the windows for the ventilation, so it require only one what we can say energy source or illumination of light. So that we are planning with the help of this ANN and SVM.
Okay, and related with the accuracy?
Accuracy for that, we have gone through some literature review, and we have compared that. Actually, here I've only mentioned SVM and ANN, but also we have tried with different algorithm like LSTMs and ensemble model. But this too is give the good accuracy. That reason I have emphasized over here.
Okay, thank you, Yogesh. Over to Ishita.
Thank you, ma'am. I'll move on with the next presenter. Once again, we have Ma'am Nikita with us with a paper titled Smart Park Navigator Simplifying Urban Parking Challenges. Ma'am, if you're ready, then you may start with the presentation.
Am I audible?
Yes, ma'am, you're audible.
Can I share my screen?
Yes, ma'am, go ahead.
Yes. Ma'am, is it visible?
Yes, ma'am, it is visible.
Yes, ma'am. Thank you, ma'am. Good evening, everyone. Once again, this is I'm from Delhi Technological University. We have developed basically we have developed a smart parking navigator which simplifies urban parking challenges which is faced by many of the metropolitan cities currently. Rapid urbanization and population growth in India have led to severe parking problems, especially in, as I mentioned before, metropolitan cities like Mumbai, Delhi, Bangalore, and Hyderabad. This is because lack of designated spaces in cities causes traffic congestion and safety risks. Limited parking in apartment leads to disputes, and as we know everything, malls and hubs face gridlocks due to inadequate parking management. Smart parking systems use IoT and data analytics to provide real-time parking availability, optimizes space use, and enhance urban mobility. The main motivation is especially in urban cities, the immediate concern of parking congestion has been a big hurdle to the citizens of these cities, and with increasing traffic congestion, air pollution, and frustrations among motorists, need modern ways of addressing this challenge device as part of improving urban mobility and the quality of life. In this regard, the creation and integration of a smart parking system is expected to solve a number of challenges that have been described above. Sorry, ma'am, I have forgot that. I thought it's in slideshow mode. Here comes the main block diagram of the entire system, where we have integrated a control. The control unit mainly consists of a node MCU, which is basically a ESP8266 microcontroller. But we have integrated ESP8266 with IR sensor and servo motor. We have provided a power supply to this ESP8266 through a power supply. We have also integrated an LCD display to this control unit in order to display the the status of the parking slots. And we have got two mechanisms, two types of mechanisms. One is exit gate and entry gate. And here we have got two parking lots. This is basically developed for two different buildings. This is parking lot 1 and parking lot 2. We have got 6 IR sensors in both the parking lots. Each IR sensor refers to one parking slot, which basically monitors if it is vacant or it is occupied by some vehicle. The entire system goes in this way. First, when we initiate the system, the IR sensor checks whether the parking slot is available or not. If it is, there is no slot, it continues to monitor, like it goes to the next slot and it monitors whether the upcoming slot is vacant or not. If slots are available when the car enters if the car enters the particular parking slot, which is detected by an IR sensor, the gate has to be opened, which is simulated by using a servo motor. Next, once the car has occupied the particular parking slot, then the status has to be updated. Like if a car, there are 3 vacant slots. If a car has come and if it occupies that particular slot of those 3 slots, then we can say that there are 2 empty slots out of 3 available slots. This is the actual architecture of the entire system, where we have developed the system for 2 buildings. This is slot 1, slot 2, slot 3, and this is the slot 1, slot 2, slot 3 of the second building. We have integrated ESP8266 with the IR sensors in order to monitor the vacant spaces. And as servo motor, it acts as a gate. Like when if a car is being detected, if a vehicle is being detected while entering the parking, then the servo motor acts as a gate. These are the results which we have achieved, ma'am. Here we can see that there are now available 3 slots. There are actually 3 slots, out of which 1 slot is available, and one slot is available of 3 slots. And we have, this is of building 1, and then the same goes with the building 2, where there is only 1 slot is available out of 3 slots. This is the thing which we have developed. You can see the servo motor, and there are like IR sensors which acts as a various parking slots. We have integrated the system with a web application called Firebase, where the user can a particular user can track the real-time data of the parking slots. Here we can see like there are 1 slot is available out of 3 slots, and the number of slots have been occupied is 2. The same goes here, ma'am. Like there are 2 slots have been 2 slots are available out of 3 slots, and 1 slot is occupied by one of the vehicle. The conclusion goes with like the smart parking project offers a significant leap in professional urban infrastructure management, powered by technology for better efficiency and a superior user experience, answering modern challenges in parking management. With the integration of sensors, automated gates, real-time data analytics, and user-friendly interfaces, the resultant and tangible benefits will be reduced congestion, improved traffic flow, and thus more convenience for drivers. It innovates operational efficiency and enhances urban mobility while contributing to a more sustainable environment. As cities grow and urbanization increases, smart parking systems can scale up the solution of managing parking resources effectively and adapt to the evolution of urban needs. We can still more develop this particular project by implementing RFID based entry and exit system to track vehicle timing and automate data logging. Introduce automated payment slips generated based on parking duration integrated with RFID system. Expand parking slots by designing modular and scalable architecture for larger parking facilities. Enhance real-time slot monitoring using advanced IoT sensors and AI-driven predictive algorithms. These are the references which we have went through in this project document. Thank you.
Nice experimentation, Nikita, madam.
Yes, ma'am. Thank you, ma'am.
No questions.
Yes, ma'am.
Over to Ishita.
Yes, ma'am.
Thank you, ma'am. We have our last presenter for the day. I'd like to invite paper presenter Swati with the paper titled Solution of Boundary Layer, Blaisius Equation by Physics-Informed Neural Networks and Cubic Spline, a Comparison. Ma'am, if you're ready, then you may go ahead. Ma'am Swati?
Ma'am, am I audible?
Yes, ma'am, you're audible.
I'll just share the screen. Good evening, everyone. I am Swati S. Sankam. My presentation is on the solution of boundary layer Blaisius equation by physics-informed neural networks and cubic spline. We are actually doing a comparison. My co-authors are Dr. Divya Sadashivan, Dr. Pramod P. Nair, Anamika Devu, and myself. So the presentation overview will have an introduction section. We'll be introducing the Blaisius equations, physics-informed neural networks, cubic splines, its methodology, the results, and the conclusions. So introduction. So what we have done during for the paper is that we have found the solution of Blaisius equation using pins and the solution of the Blaisius equation using numerical method, that is cubic spline method, and we had actually compare the solutions. So let's discuss what is, first we'll be discussing about this Blaisius equation. Blaisius equation is a third order nonlinear ODE, that is ordinary differential equations, that makes the models the laminar boundary layer flow of a fluid or over a flat plate. This equation arises from simplifying the Navier-Stokes equation under the assumption like steady flow and incompressible fluid. F triple dash plus half F dash into F dash into F dash is equal to 0 with boundary conditions. The initial conditions F of 0 and F dash of 0 will be equal to 0, and at infinity it will be equal to 1. The solution help in calculating the fluid velocity profile, shear stress, and the drag coefficients, which are essential in designing aerodynamic surfaces, marine vessels, and other engineering applications. It is actually nonlinear and requires advanced computation. This paper compares two methods, that is the physics-informed neural networks, a modern machine learning-based approach, and the cubic spline interpolation, a traditional numerical technique. The goal is to assess their accuracy, computational efficiency, and suitability for solving Blaisius equations. Physics-informed neural networks are embedded physical laws like PDEs and RDEs into the loss function of a neural networks. The network learns solution by minimizing the residual of these equations while also fitting observed data if available. The loss function includes data fitting term. It ensures solutions align with observed values. The physical residual terms enforces the governing equation constraints. The key features are encoding the physical constraints within the loss function. It solves the complex problems without explicit discretization, and it automates the computation of derivatives via automatic differentiation. We use pins to solve Navier-Stokes and the boundary layer equations. It can also be used in seismic and imagine and wave propagations, and the challenges faced were high training time and the memory usage. We had to use a very careful loss functions. So the challenges were high training times and memory usage and requires careful tuning of loss functions for stability and accuracy. Splines are piecewise polynomial functions that is used for interpolation and approximations. Cubic spline interpolation specifically involves joining cubic polynomial segments between these data points to form a smooth curve. A cubic spline is a function s of x such that it's for every data point s of xi and yi, we have a function s of xi, and it is smoothened in the first and second derivatives. The advantages were the features of cubic splines are it is widely used for interpolations in engineering and computations. Its smoothness ensures continuity and differentiability, and it is versatile for interpolation and curve fitting. It is computationally efficient and straightforward for low dimensional problems. It guarantees smoothness and continuity of the subject. The limitations we faced there, it is not ideal for high dimensional problems. It is not smooth for irregularly spaced data. The methodology, the nonlinear Blacher's equation was linearized. We performed the Taylor series expansion around a chosen set of points, and it was truncated at our first order term, resulting in the linear approximation suitable for the analysis. We implemented this using Python and different libraries, for example, TensorFlow, everything. This is the graph of the linearized the Blacher's function, and we use NumPy, SkyPy, Matplotlib, and everything for the visualization and the computations. We first define Blacher's equation and the boundary conditions. Then a mesh of independent variable values were chosen. The boundary value problem is then used with solve BVP function from SkipY, which is from Python. Then the two smooth curves are plotted, which shows the comparison between pins and the cubic spline Blacher solution. So the computational efficiency, pins, the strengths of pins are it is suitable for high dimensional and complex problems, and it is efficient with sparse and irregular data. The weakness, high computational cost and GPU dependency and long training time due to iterative optimization. And for cubic splines, the computational effect is for 1D or 2D problems rather than higher dimensional problems. It requires minimal computational resources, and the weakness is where it was poor scalability to higher dimensional problems and less adaptable to irregular geometries. It is observed that there is no visible between the two curves. Both the solutions that we found using pins and the cubic spline actually they coincided. The dotted one was used. The dotted graph is found using the pin solution, and the cubic spline solution is shown using the yellow dotted lines. And the value of the second derivative we got this of a f at 0 was we found was 0.344, and we compared with the solution with the paper from Grishma Krishna and our co-author Pramod sir, and the solution that they got was 0.332, and the solution that we got was 0.344. So in conclusion, we can say that the both methods demonstrated comparable accuracy, but pins may offer advantages in handling more complex fluid dynamic problems, especially with limited data or when physical intervality is crucial. These are the papers that we referred. Thank you so much. Any questions?
Very nice comparison also you did, Swati. No questions. Over to Ishita.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. This was our last presentation for the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2024. I'd also like to thank our session chair. Just a second. Dr. Latika Desai, for chairing the session. A token of appreciation to the chair on behalf of Team ICTCS 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am.
Thank you, Ishita.
Thank you, ma'am. Right before we end the session, I'd like request to everyone to please turn on the cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.